In this video, I'll be helping you with a math topic called factoring the greatest common factor. And this example is taken from the OpenStax College Algebra text. We're given both the definition of the greatest common factor, stating that it is the largest polynomial that divides evenly into the polynomials. We have our example here, and we're also shown at the bottom the steps for factoring out the greatest common factor. Starting with identifying the GCF of the coefficients, our coefficients being 6, 45, and 21, the greatest common factor, or the largest number that divides evenly into each of those, will be 3. And then we are to find the GCF of the variables. So the variables, x to the third, y to the third, x squared, y squared, and x and y, we can say that each of those have at least one x and at least one y. I can't say that they all have more than that because the last one only has one x and one y. Now that we've identified both the GCFs of the coefficients and the variables, I can combine those into a 3xy. That's our GCF, and that's what we'll be factoring out of this expression. And we're told to determine what the GCF needs to be multiplied by to obtain each term. So if I factored out that 3xy, what would I need to multiply by to get this first term? Well, first I would need to multiply the 3 by 2. That would be our coefficient. The x would need to be multiplied by 2 more x's to give us the x cubed. And the same for y. I would need to multiply by 2 more y's to get 3 y's. By the way, another way to think of this is just to do division. 6x cubed y cubed divided by 3xy would give me the 2x squared y squared that I have here. But continuing to think of it in terms of what do I need, for the next term, I've got a 45x squared y squared, so I would need to multiply this 3 by 15 to get 45. I would need to multiply the x by 1 more x to get x squared, and then I would need to multiply the y by 1 more y to get y squared. So we've taken the GCF out of the first term and the second term. For the third term, I've got a 21xy. I would need to multiply this 3 by 7. But since I already have the x and the y in the 3xy that I need for the 21xy, no other variables are needed. I've written the expression as the product of the GCF and the sum of the terms we need to multiply by. So this would be our factored expression factoring out the greatest common factor.